Okay, thanks for coming here to watch or rewatch how to the pattern for the unit circle. And so it has a very distinct pattern that you want to memorize. You can fill it out for the test. And so that pattern works out because of the special qualities of the unit circle. And so first and foremost, a unit circle always has a radius of 1. Always has a radius of 1. Now let's see. So we'll start off here with, so basically these ones in parentheses, these are all your homework answers and all your test answers, right? So you definitely want to be able to put in the degrees, the radians, and then the test answer. So for example, we know just starting here, going across here, we know that this has a radian or a degree of just 0 degrees. And then if we convert that to radians, 0 times pi over 180 is going to be 0 times anything is just 0. So 0 radians there as well. We also know that if this is a radius of 1, that for the x-axis, if this is an x-axis and this is a y-axis, that we already know a test answer here, a coordinate, and that coordinate is over 1 up 0. Right? Just like on the x-axis, over 1 up 0. If this was a big grid, this would be just the first grid, just over 1 and then up 0. So over 1 and up 0. Okay, now let's see here. We also learned that this first answer is cosine, and this second answer, 0, is sine. So just think about it alphabetically. Cosine is C, and then what comes next is C before S, so C and then S. So cosine and then sine for all of these all the way around. Cosine, sine, cosine, sine, cosine, sine. So those are all cosine, sine all the way around. Now to make sure that we understand these homework answers, what if I asked you on the test to find cosine of 0 degrees? Well, you would go make sure you're in degrees first. So we go mode. Oops, I'm in radians. So degrees. And sometimes you need to be in degrees, sometimes you need to be in radians. So cosine of 0 degrees is 1. Sine of 0 degrees is 0. And that matches with our unit circle, 1 and 0. Cool. Now let's just focus on the degrees for now, filling out the unit circle with degrees. So this is 0 degrees, good. And then we're going to go ahead and use the unit circle and use the right triangles that are formed in the unit circle. And so this first angle here that we're going to use, so each of these spaces, I think you already know, that don't you already know that? That all the way around is 360 degrees, right? Yeah. So a full circle is 360 degrees. So that means if you take it and you split it up into this many even sections, can you see all these triangles all the way around? Or not triangles, but sections. So here's one section here. Do you see it? And then here's another section, another one, another one. Yeah, you see all those sections all the way around. So there's, let's see how many there are. There's a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think there should actually be 12. I think I'm missing one. Huh. Yeah. 1, 2, 3. Oh, 3, sorry. And then this is its own 4, 5, 6, 7, 8, 9, 10, 11, 12. Cool. So that means that each of these, so if we take 360 and divide it by 12 even sections, that's what we do with the unit circle. And so 360 divided by 12 is 30 degrees, 30. So each one of these little sections that we've made there is 30 degrees, okay? So we'll start off with that. So that means that this is 30 degrees. And so here's your terminal side of your angle there to represent. Here's your initial terminal side. And then up to here is 30 degrees, right? 30 degrees. Okay, so this is 30 degrees. Okay, that means that if we go another full 30 degrees up to here, that would make this 30 plus 30 is 60. And I've skipped this little one, but we'll still tell you what it is. So the little one is half a 30. And what is half a 30? 15. So 30 plus 15 is 45. So those little ones are just 45 angles. So now we can go ahead and fill it out all the way around. So 30, 60, 90, right? And then from 90 we add 30 more. From 90 we add 30 more, 120. And then add a little 15 there, which make it 135. Add another 15, or 120 plus 30 again is 150. Good. And then you remember what half a circle is? Well, 150 plus 30 is 180. Good. Add another 30 to 180, you get 210. Add 15 to that to get this little angle. That's 225. Add another 15, you get 240. Now, that was adding 15 is what we just did there. Now, and then another 15 is 240. Now we're going to add another 30. So 240 plus 230 is 270. Good. And then plus another 30 is 300. Plus 15 is 315. Plus another 15 is 330. And now we arrive back at our circle, full circle, 360 degrees. Cool. So there's your degrees. We added by 30. 30, 30, 30, 30, 30. So instead of adding 30, 30, 30 now with radians, we'll add whatever the radian equivalent of 30 is. So we'll take 30 degrees. To convert it to a radian, it needs to have a pi, so we times it by pi over 180. Good. And so now we have 30 pi over 180. Now to convert it from 30 degrees to a radian, we do have to reduce it. So we have 30. I'm thinking that 30 might even go into 180. Let's see. So we could probably divide by 30 to both top and bottom. We can. So we're going to go ahead and divide by 30. Divide by 30, thereby reducing it. And so that's just going to be 1. So 1 pi over 180 divided by 30. We figured that out. It was 6. Good. So 1 pi over 6. That's your key. Instead of adding 30 degrees plus 30 degrees plus 30 degrees plus 30 degrees, you're going to add by pi's over 6. So this is 1 pi over 6. We're going to skip the other ones for now. I'll circle them because they're special. They're like half of 30. So we're going to put a little red box. You can too. They're special. They have their own pattern. So we'll come back to those 4 of them in a second. Okay, so now we're going to go ahead and do by 1 pi over 6. I'm not going to write it in the square yet because we do have to reduce it, but I'll still put it right next to it. So 1 pi over 6, and then we add 30 degrees, or add another pi over 6. So now we have 2 pi over 6. And then the next one over here would be 3 pi over 6. And so you could reduce them. Some of you want to already. So 2 pi over 6, if you divide by 2, you're right, you'll get pi over 3. 3 pi over 6, divide by 3, you get 1 pi over 2, or pi halves. But we're counting by over 6, so just fill that out before you reduce it, just count. So 1 pi over 6, this is 2 pi over 6, this is 3 pi over 6, this is 4 pi over 6. This one, next one down here, we can fill it in because it's already reduced. So 5 pi over 6. This one is 6 pi over 6. Oh, the 6 is canceled. Just pi, which is half a circle. Good. So 6 pi over 6. 7 pi over 6. You starting to get the pattern? 8 pi over 6 does reduce, so we can't put it in yet. Same with 9 pi over 6. Over here is 10 pi over 6. Over here is 11. Oh, we can put that one in, actually. 11 pi over 6. And then the last one is 12 pi over 6. And what is 12 pi over 6 reduced to? Well, 12 divided by 6 is just 2. 2 pi, which is a full circle. 360 degrees, or 2 pi. Cool. Now, if you're struggling, you can times them by pi, like 360 times pi divided by 180. 360 divided by 180 is 2, so 2 pi, that makes sense. Cool. All right, so now that we've got the degrees and we got some of the radians, we're going to go around and reduce some. So we already reduced 2 pi over 6 is pi over 3. 3 pi over 6 reduces to pi over 2. 4 pi over 6 divide by 2. We get 2 pi over 3. And then 5 pi over 6 is okay. We got pi. 7 pi over 6 is okay. Oh, 8 pi over 6. That divided by over 3. 9 pi over 6 reduces to 3 pi over 2. 10 pi over 6 reduces to 5 pi over 3. Just reducing, divide by 2, divide by 2. And then 11 pi over 6, 2, and 2 pi. Cool. So now we got all the radians filled out by adding 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6. Good. Whew. Now this other pattern, the 45-degree angles, that one actually, we'll do it in red. So those ones are a little bit more special there. And so those ones go by, well, let's see, 45 times pi divided by 180. I'm going to leave off my pi for a second and just do 45 divided by 180. We'll get a decimal answer. I want to turn that into a fraction, so I'm going to math button math fraction, 1/4. So that reduces to just pi, 1 pi over 4. And that's what I'm going to count by. So 1 pi over 4, or just pi over 4. So 1 pi over 4. Then the next one, we're skipping like this now. We're basically doing like fourths there, or whatever it's called, eighths. So 1 pi over 4. Then the next one over to here next is 2 pi over 4, which reduces to 1 pi over 2, which we already have. And then over here is 3 pi over 4. Over here is 4 pi over 4, which just reduces to pi. Good. Over here is 5 pi over 4. Down here is 6 pi over 4, which again reduces to 3 pi over 2, which we already have right there. And then 7 pi over 4. And then 8 pi over 4, which just reduces to 2 pi again. Back to the end, back to the beginning of our circle. We've gone one full circle. Bam! So there's your radians, there's your degrees. Okay, so now we have all those. So on the test, we're going to ask you to, like for example, well, that's the same as sine of 30 degrees. Those are both equivalent. But what is that as an exact answer, right? That's what we're going to ask you on the test. What is that exact trig answer? Not a decimal. I know you can plug in your calculator and you'll get a decimal. But not as a decimal. We need it as a radical, as an exact answer. So how we can do that is filling in the rest of the pattern for the unit circle. And so the unit circle uses right triangles. So using right triangles, we already know this is a 30 right triangle. That means if this is 30, well, if this is 30, that means that if I carry this to that point right there, we'll get rid of these red and blue lines to help us see our right triangle in green there. Okay, so that's 30 degrees all the way to the circle, and it has a radius of 1, and that means this is 60. We have a 30, 60, 90 right triangle. Woo! And so the radius is 1, good. And so how do we go from the hypotenuse of 1 down to the short leg? You remember from last section that we were dealing with? Well, you take that hypotenuse, which is 1, and you just divide it by 2. Bam! And that's the what value? That's the y value. That's the y value. So that goes right here. That's a half. And if you don't believe me, ready? Sine of 30 degrees is equal to a half. Bam! Cool. Now we need to know cosine. You're like, well, I could just plug it in. I don't need the unit circle. I can just calculate. Well, I don't know about that, because cosine of 30 degrees is some crazy 0.866025438, blah, 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 blah. And that's not an exact answer. So we do need to finish our units. We do need to finish our 30, 60, 90 right triangle. So now we got to go from the short leg, this is the short leg, to the long leg. This right here, this distance is the long leg. And so to go from the short leg to the long leg, we have to multiply by something, make it this much bigger. Do you remember what it is from last quarter, from last unit? We do have to multiply it by radical 3. So we're going to take 1/2, and we'll do it in green. And we're going to take 1/2 like this, and from our short leg, and we're going to multiply it by radical 3. That's what we learned last time, that to go from the short leg to the long leg, you just multiply it by radical 3. So now we get radical 3 times a half is just, radical 3 over 1 times a half is just radical 3 over 2. So this long leg then is radical 3 over 2. And that's this distance, this x is equal to, that's the x distance, radical 3 over 2. Beautiful. And so that, my friends, and a shout out to Eve. Yeah, Eve, this is for you. Hope you're still watching it. Keep watching it. So radical 3 over 2. So if we go to our calculator and put in cosine of 30 degrees, you get 0.866. And if you want to check your answer using your calculator, we're going to go ahead and divide that by radical 3 over 2, which is 0.866025438. Cool. So cosine of 30 degrees is definitely radical 3 over 2. Cool. So we're going to ask you to find sine of 30 degrees or on the test, the exact trig value. Well, what if it's all the way over here, Mr. Newbold? What if it's like all the way across and we do this one? What about 150 degrees? What'd you have to do? 50 degrees? Well, it's going to be the same. What do you mean, Mr. Newbold? Well, you'll see a pattern here, right? You'll see a pattern that from here, so straight across, is the same thing. Radical 3 over 2, comma 1/2. Really? Yeah, totally. Except for we are on an xy axis, and we went left negative radical 3 over 2. And then we went up 1/2, right? So the 1/2 is positive, but the negative radical 3 over 2, the radical 3 over 2 is negative. So if you want to like put that on your unit circle here, so that means that this side, they're both positive, the left coordinate and the right coordinate. Quadrant negative, but the y values are positive. Down here, they're both negative, negative. So all your answers are negative in the third quadrant. And then down here in the fourth quadrant, it's they're positive, but then down on the y value, so negative. So that'll help you there in filling out the unit circle. Cool. So now let's keep this all the same color coordination so you can kind of see it. Why don't we choose purple? So again, this is radical. Whoa. Good. Okay, so radical 3 over 2, comma 1/2. And then directly across over here is negative radical 3 over 2, comma 1/2. That means that directly down, follow the line. Directly down here, so just straight down there, is also, but they're both negative, radical 3 over 2, negative 1/2. Then going this way across. Or you could even think of it diagonal. Look at that line going diagonal. Yeah, that's also radical 3 over 2, comma 1/2. Except for the half is in fact, negative over on this, on the fourth quadrant. Negative 1/2. Cool. And then that radian was pi over, oh, what the crap did I do there? 5 pi over 10 pi over 6. That was supposed to be 11. Sorry about that. 11 pi over 6. Yeah. Cool. Okay, so good. That's that one. Now you'll notice our triangle has changed a little bit up here. Look at this point. So that point is now a smaller angle up top and a bigger angle down below. So that's 60 degrees is what we're dealing with now. Get rid of that 30. That's 60. 30's up here. All it does is swap it. Right? All it does is swap it. So that means over here is going to be 1/2, and then the second will be radical 3 over 2. So and over here too. So that means towards the y value, you're going higher with your radical 3 over 2. You're 0.866, right? You're going higher. So those ones are up higher. So that means that over here is also the opposite now. 1/2 radical 3 over 2, but the half is negative. And then directly below, follow the line down as far as you can go. And down as far as you can go, this one is, let's see here. So left, negative 1/2. And then negative down, the bigger number, radical 3 over 2. Then going across over here, this one is positive 1/2, but down a distance of radical 3 over 2. And you can see that it's diagonal of that one right there, which is the same, half radical 3 over 2. Cool. Now these other ones, so pi over 4 are 45 degrees. These ones have their own special unique pattern, their own special x value and y value. And, can you guess it? Okay, so that's this triangle now that we're talking about. That's this triangle. Oh, doesn't that triangle look like the angles are the same? Why, yes they are. Good judgment there. So, by Jove, I think you've got it. So if that's 90 degrees, well, two angles that are the same would be the 45, 45, 90 right triangle. Bam. And so we have a hypotenuse of 1. And so to go from a hypotenuse 1 to the small leg, you divide by, do you remember? Going the other way, you times by radical 2, but going smaller, we divide by radical 2. So we get 1 over radical 2 for our x value, 1 over radical 2 for our y value, except for you can't have radical in the bottom. So you do have to times it by radical 2 over radical 2. And so you do get radical 2 on the top, because radical 2 times 1 is radical 2. And but on the bottom, you get radical 4, because 2 times 2 is 4. And the square root of 4 is just 2. So radical 2 over 2 is what these ones are. Radical 2 over 2, radical 2 over 2. This one is a negative radical 2 over 2, comma positive radical 2 over 2. Down here, they're both negative. Radical 2's over 2's. There you go. And then over here, the radical 2 over 2 and the x value is positive, but the y value is negative. Cool. Bam! Filled out the whole unit circle. Nearly. So all we have to do now is we have 1 comma 0 is for our quadrant angle of 0. Then we go to 90 degrees. Hello, 90 degrees. What are your answers? And so your answers are sine and then cos. No, careful. Sine is, whoa, Mr. Newbold. S comes after C, Mr. Newbold. So cosine and then sine. Okay. So 90 degrees. Well, if this is a radius distance of 1, which it is, you're going to go over 0 on the x-axis and up 1 on the y-axis. Over here, you guessed it, left 1, but up 0. And then down here would be over left and right 0, but down negative 1. Now you filled out the whole unit circle. Woo! How beautiful. So you're going to do that on the test and use these as answers. And so if I was like, Newbold, what about if I get like, I don't know, cosine at 225 degrees? Well, then you're going to go define, here it is, I'm circling it, 225 degrees. You said cosine, well I know that cosine is first, so the answer of cosine of 225 degrees is negative radical 2 over 2. Bam! There's your answer. So use this, you're going to use the unit circle to find the exact trig values. Now, again, if you do come up across with a tangent, well, we're only dealing with cosine and sines. So you're going to have to realize that tangent is equal to sine over cosine. You're going to have to memorize that. You also have to memorize that cotangent is the opposite, cosine over sine. You just have to do two different problems and put them as a fraction over each other and reduce. Also, I could ask you on the test, I'm going to do it over here. I could ask you, you need to know what cosecant is. Like cosecant of 150, same as just doing 1 over, what's cosecant? It's sine, 1 over sine. So because c and s are like opposites of each other, cosine and sine are opposites of each other. So 1 over sine of 150 degrees, beautiful, 1 over sine. So then you'd find sine of 150 degrees, there it is, and sine is a half, and you'll just have to flip it. So the answer to cosecant of 150 degrees is just 1 over a half, which flip it, it's just 2. Cool. So you'll need to know cosecant and tangent and cotangent. And the other one you'll need to know, secant. So let's say I had to do secant of 150 degrees, well, on the test, or even call it, instead of 150, let's call it 5 pi over 6, which is the same as 160. And so then to find secant, you'd have to do 1 over cosine, right? The opposite of s is c. Opposite is sine, cosine. So secant is 1 over cosine, and then 5 pi over 6. So then we go to 5 pi over 6, there it is. And then cosecant is, or cosine rather, cosine, sorry, is of 1 over cosine of 5 pi over 6 is 1 over whatever cosine of 5 pi over 6 is. And cosine of 5 pi over 6 is negative radical 3 over 2. So 1 over negative radical 3 over 2. Now, this is where the problem becomes a little bit hairy, scary, but you'll get it. This might be the harder one on the test. So then you can't have a fraction there, so you can't have a fraction within a fraction. So you'd have to flip it. What do you mean flip and multiply? I mean times by negative 2 over radical 3. And then times by negative 2 over radical 3. And so the radical 3's cancel and the 2's cancel. Negative times negative is a positive. That all cancels. And then you're just left with 1 times negative 2 over radical 3, which is just negative 2 over radical 3. And you can't have radical 3 in the bottom, so you have to multiply it by radical 3 over radical 3. So we get negative 2 radical 3 over 3 times 3 is radical 9. And square root of 9 is just 3. Whew! So that's a tough one. Negative 2 radical 3 over 3 is the correct answer for which one? For 5 pi over 6. Now, if we did that on a calculator, matches up and works because you can use your calculator to check your answer. You would go to 1 over cosine, so 1 divided by cosine of 5 pi divided by 6. And because I'm in degrees, it'll give you the wrong answer. Crap. What do you mean? Oh, mode, I got to be in radians. So sometimes you have to be in radians, sometimes you have to be in degrees, so be careful there. Okay, now we'll do it again. Ah, there we go. But that's not the right answer. Or is it? Negative 2 times radical 3 divided by 3. Bam! Bam, bam, bam! So there you go. We just see here that negative 2 radical 3 over 3 is the correct answer. That's what you have to put on the test. This is your test answer, not the decimals. But the decimals prove that they're equal to each other, but you definitely have to put the exact answer. So the decimals are equal to each other, which is good. That means you did it right, but you are going to have to put negative 2 radical 3 over 3 for your test answer. Whew! Thanks for watching, fast forwarding it, and learning. Appreciate you, especially you, Ebe, Nate, Alex, everyone in second hour. You guys are awesome. So thanks for watching, and appreciate you. Peace out. Study hard for the test. Bye for now.